There you go. We live. Let me just verify it on my burner, like usual. Then we're gonna go into some practice questions. Nice. Let's see. I have to click in. Increase the font. Increase, toggle in. Ooh, it's hot. All right, let's just get warmed up. I've been a code. Let's get it. 10 minutes. Solving this one question right now. Trying to figure out how to solve it quick. So if I have so what's going on here? While left is less than right. If I get to end, I'll reverse. If I find something that's smaller, I need to find the first element that's smaller. First element that's larger than me. I do. First element larger than me. We're given nums, given an index. Usually we'll start at index equals length of while given a target, while the nums at index is less than equal target, index minus equal 1, and return the index. Yes, sir. Gotta grind that Leetcode. Just doing some warm-up questions. So I need to figure out who we're gonna swap. First larger element. I'll get what if num's index is less than num's index plus 1. That's when we notice the drop. Hey everyone, I'm just literally coding, just doing some warm-up Leetcode. Next permutation. Kind of annoying question. This question cost me a bag. I fumbled it in an interview. But essentially what we want to do is we want to check when it's monotonically or just when it's increasing, and the moment it drops, we're going to capture that element. And we're going to find the next element that's larger than it and swap it with that. And then we're going to reverse the back part of the array. Something like that. 7 minutes. So we found the element that's index. Okay, first larger element, and then we pass back nums. Then we'll pass back the current index. Then we'll say index, swap index here, and then pretty much we just reverse the back half after swapping it. Should work. So sick. Submit. What? Use this test case. Two, 3, 1. Okay. Exit here. What's the index that if swap that? So stopped at 2, 3, 1. Stopped at the 0th index. You need to swap the 3 here. Okay, let's see what the swap index is. First element larger. First element. Okay, 0, 1, 2. How? Oh, shoot. Little mistakes. Let's pass that in. Please work. Nice. O of 1 time complexity, or O of n space complexity, O of n space, and then O of 1, or of 1 time, O of 1 space. I'm going to do a video on how to do this question. Literally just waiting for this thing to drop. This new question. Let's get it. Let's position some input. So usually we want to get some input string. Dot. Four minutes. Send the stream off to some people. It's been a slow day. It's 3 minutes. Let's get it. Wonder what this one's gonna be about. What's the story so far? I literally didn't read yesterday because I just went straight to the problem. Nice, Florida man. You're gonna hop in today? I'm gonna send you the link. Florida man. Yo, John, he's also in comp sci, where he's doing his degree. Florida man, you're hopping in today for the yeah, hop in the challenge and then just I'll help you out. Ask some questions if you get stuck, but I feel like you're good. You'll be able to solve it. John, hop in the advent of code, bro. You finished? Finished what? I'll get you. Let me ask my boy. He has it. Change the name of the server. Server settings. Brother, I'll get it to you soon. I'll get it to you soon. Oh, did the question drop? Oh, almost tweaked. Bro, I didn't even know how to do a class. Don't worry. You don't need to. Come on, let's drop. Yeah, you can. Let's see. What the first question? Let me see. Dude, the first question is so easy. You actually got this. The very first day is pretty good. And yeah, you could do everything with using functions. Essentially. And Florida man, I'll be running the Discord after. I have one already. I just need to figure out how to do that. Might take me a second. John, start with like, yeah, try like the first day. Yo, Nathaniel, is my stuff better today? The setup? Florida man, let's get it. Okay, satisfied with their search on Cerise. The squadron of scholars suggests subsequently scanning the stationary stacks of sub-basement 17. The North Pole printing department is busier than ever. This close to Christmas, and while historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. A lot of times it's like pointing to other advent of codes, like from 2017. Yeah, you should do questions. Drop one on some easy questions and just let's see your progression over time. So let's see. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. Is this the same day? Okay, 24. The notation X means that if both pages, page number X, and are to be produced as part of an update, page X must be printed at some point before Y. Oh my gosh. He's from Florida, man, but he's gonna come to SF apparently. You see, the elf has for you both the page ordering rules and the pages to produce in each update. This is like definitely a graph problem. I need to read this again. So, the elf. The elf must recognize you because they waste no time explaining that this new sleigh launch safety manual updates won't print correctly. Failures to update the safety manuals won't be dire indeed, so you offer your services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation XY means that if both page number X and page number Y are to be produced as part of an update, page X must be printed. Okay. The elf has for you both the page ordering rules and the page to produce in each update. Okay. means that if an update includes both page 47 and page number 53, then page 47 must be printed at some point before page 53. What's up, John? Oh, this is a definitely like a graph problem. This is like a course schedule problem. Dude, the output is huge. Okay, wait. I just need to... Okay, this example. It is complicated, but we can solve it all together. Don't worry. The ELF has for you both the page ordering rules and the page to produce. What the heck is this ELF even doing? Sometimes knowing like the part up here is useful. Satisfied the squadron. So we're looking for Santa. What happened in this story is Santa disappeared and we need to like find Santa. That's essentially what these next 25 days is going to be. So satisfied with their search on Cerise, the squadron suggests we're looking at a specific basement. The North Pole printing department is busier than ever this close to Christmas. While historians continue their search of this historically, an elf operating a very familiar printer beckons you. The elf must recognize you because, okay, the elf is trying to recognize us. Because they waste no time explaining that the new sleigh launch updates won't... Because they waste no time explaining that the new sleigh launch safety manual updates won't print correctly. Don't worry, Florman. I already have an idea of how to do it. Do not worry. Failure to update the safety manuals would be dire indeed. So you offer safety protocols indicate that new pages for the safety manuals must be printed it needs to be printed a very specific order. X. If both number X and are to be produced as part of an update. Okay, because so are we making updates to this thing? Okay, we're making updates to the same safety manual. There's so much text here. Failure to update the safety manuals would be safety clearly indicate that new pages for the safety must be printed in a very safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation XY means that if both page number X and page number Y are to be produced as part of an update. Yeah, this is way too much. I don't really need to know this, but I kind of want to... I could probably just go straight to a question, but I kind of want to know the story just for fun. So very specific order. The notation means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before Y. So it's we're kind of building a dependency here, and that's why I'm starting to think it's going to be some sort of graph problem. Because X must go before Y. The ELF has for you both the page ordering rules and the pages to produce in each update. Okay, so we're given the page ordering rules. Oh, so we pretty much will probably need to parse that into a graph, and then the pages to produce in each update. But you can't figure out whether the update has the pages in the right order. Okay, that's making sense. A bit. So the first section specifies the page ordering rules, one per line. The first rule, 4753, means that if an update includes both 47 and 53, then the page number 47 must be printed at some point before 53. I mean, we could even brute force this so hard. Okay. So what I'm thinking is we need to get for every number we just need to know who should have came before it, and then just like check. Means that if it includes both 47 and 53, then page number 47 must be printed at some point before 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be between them. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update means that the updates consist of pages. To get the printers going as soon as possible, start by time updates are already in the right order. Okay, we just need to check which ones are in the right order. In the above example, the first update is in the right order. 75 is correctly before. Okay, yeah, I like this question. For each number, we just need to create a set of all the numbers that need to come before it. And then we could kind of like check that. Brute force. 47 is correctly. Okay, 47 is correct because 75 must be before it. Because of that. And every other page must be after it according to. Okay. Ooh. There's like some topological sort. Oh, okay. I see how we can do this. Yeah, we have to do like some sort of topological sort. Wait, let me think. 61 is correctly because, yeah, this one's actually way harder. Because the first update does not include some page numbers, the ordering rules involve these. Because the first update does not include some page numbers. Okay. The second and third updates are also in the, because of the rules. The fourth update is not in the correct rule. Because 97. Okay. Okay, cool. So basically we need to build this dependency graph, and then after that we just need to verify. For some reason the elves also need to know the middle page number of each update being printed. What does that mean? Because you're currently only printing the, you'll need to find the middle age number. Who's spamming the stuff? Okay. For some reason, the elves need to know the middle. I need to focus up, actually. I'm going to put that chat to the side. For some reason, the elves need to know the middle page number of each update being printed because you're currently only printing the correctly. You'll need to find the middle page number of each correctly. Okay. Oh, okay. I see. Interesting. These will have middle page numbers of 61, 53, and 29 respectively. But what if there's two middles? Like what if we have an even number? It makes sense. Which number are we gonna take? Determine which updates are already in. What do you get if you add up the middle page number? Okay. So now pretty much what I'm gonna do is I need to parse this output, and I need to figure out like what needs to come before what. Because it means that if both. Okay, so for each number, I'm going to build a list of who should be before and after. So for each one, so pretend we get like a X, right? Pretend we have X, Y, Z. We get X. I just need to track in a set who should be before and who should be after, right? Are produced as part of an update. Page number X must be so pretty much when I'm looking like at a X at a specific number, I just need to look at the elements behind me and the ones for me, and each one needs to exist in my before, and each one needs to exist in my after. Each one on the left has to exist in the before set, and each one on my left has to exist in the after set. And then that once I know that, I'll know that that one's valid. But I just need to quickly check. Let's look at this. Let's just do. Okay, let's just parse this output and try that out. What happens? What happens if it's not in there? Does it matter? Safety in a very specific order means that if both pages are to be produced as part of an update. Okay, if it's not, if the number is not in there, we don't even care. Cool. Makes sense. Okay, I'm gonna just parse this output first, and then I'll build the dependency graph. I'll say 47 should. I'll say this should be okay. For each line that I'm looking at, I'm gonna put 47, and I'll say 47 after before page Y. So in the after set, I'm gonna throw 53 in there, and then the before set. In the before set, I'm gonna do 53. In the before set, I'm gonna do 47. Is that valid? XY means that if both page number X and page number Y are to produce, page number X must be printed at some point before. Okay, 47 must be before 53. Cool. So I'm pretty much gonna do that. So for each element, I'm gonna build a before and after set. And then, like, when I parse each element, I'm gonna pretty much do that. So let's just build this with one digit first. So we have 4753. Print that. Oh, shoot. Florida man, how are you doing on it? Is it hard? I had to read the question like 20 times just to figure out what's actually going on. This should be before and this should be after. But once I have a understanding, this will go a lot quicker. You both. Okay, you both. Some point before Y. Okay, so we split. We get before and after. Then I'm gonna create like a little class that's gonna be called, because I'm gonna use default dictionary. I'm gonna build a class called dependencies. Build a class there, and I'm gonna say dependencies self dot before equals a set, self dot after equals a set. And then what I'm gonna do is self dot dependencies, and we have to assume that all these dependencies are actually right. And then let's look at the output quickly. Hopefully there's actually a middle. So what I'm gonna do is from collections import default dict, and I'm gonna say, then I'll say all dependencies, all deps, those dependencies, or default dictionary of dependencies. Then I'll say, so all depths, so for before, I need to dot add after. Before set, after set. Let's say this is just X and Y. So I'll say X for X needs to come after. So for X, yeah, Y needs to come after X. And then we'll say Y dot, because this is a set of what needs to come before. I'll say after set. So I'll say for X, Y needs to come after it, and for Y, X needs to come before it. Now let's print all dependencies. What's going on? Cool. And then now let's just like parse this whole input right there. Where's this? And then we'll say say the lines here are here. Line string here. So now we parsed all the dependencies. Now we just need to verify each line and get the result. So let's just do result equals 0. And at the end, we're going to print the result. And then what we're going to do is, let me quickly check this. We're going to split this line string right here, and we're going to get all lines. Then we're going to split this. Let's do this. Make sure that's printing correctly. We're going to say for line in all lines. What we're going to do is we're going to like verify that it's correct. We'll build a function called verify index, right? And then we're going to be given a line, and we're going to be given an index, and then we're going to be given the dependencies. And then what we're going to say is left and right equals 0, and or index minus 1, and then this one's index plus 1, right? Then what we're going to do is we're going to, while left is greater than 0, greater than equals 0, we're going to decrement this counter. But what we're going to do is we're going to check if, let's call this a target. What we're going to do is, oh no, we need index here. Let's say target equals line index, right? For each line, we're going to want to split this line too. All lines dot split. Oh, sorry. Line dot split. Cool. So we're gonna, while the left is greater than equal to that, what we're gonna do is we're gonna get the candidate equals line at the left pointer if we'll say if the dependency, because we're going to look to the left of us, if the candidate is in the line left pointer, if dot after set, return false. Where's target? Wait, do we need our target? Oh yeah, we need the target. What we're gonna do, if the candidate is in, no, what we're gonna do is like we're gonna get the dependencies. So we're gonna get dependencies of like our target, which is like the middle index. And we're gonna see if anything to the left is supposed to be in the after set. If it's supposed to be in the after set, it's in the wrong order, we return false. Right. Now let's do that with the right element here. While the right element is less than the length of line, we're gonna get the right pointer and we're gonna take the right and increment it. So while we're looking to the right, if the candidate is in the dependencies.target before set, like it should have appeared before, we return false. Otherwise we return true. So let's do this index, then we'll say what we're gonna do is we're going to, for I in range length of the line, let's see, line equals split. So for I in range length of the line, what we're going to do is we're going to pretty much verify every single index. So let's say is valid equals to true. And then if is valid at the end, then we'll increase the result. Wait, I'm just gonna text my friend real quick, make sure he's on it. This guy's name. Are you on the question? It's a good question. All right, let's continue. Then we do result plus equals 1. So for I in range that, what we're gonna do is like if, then we're gonna verify index of the line. We're gonna give the index here, and then we're gonna give the dependencies. If that is false, then is valid equals false. Otherwise, like let's print otherwise we do this. So we have 3. Who's good? 97, 75, 29, 13. Okay, now we just need to extract the middle element. So how do we do that? To extract the middle element, we need to take the left plus right pointer divided by 2. Or no, we just need to take the length divided by 2. The length of the result equals the middle equals the length of the line divided by 2. And we'll say line middle, and then we'll turn this into like an integer or something. $143. What's the answer? All right, that looks like it's correct. Now I just gotta put this big output in there. Dude, that took me a lot of time just to read the question, but I think we're good. Five, 9, 4, 8. Please work, please work. Woo! 1 gold star. That was a hard question, not gonna lie. Let's go. Let's move on to the next part. It's just gonna get harder and harder. I just brute forced that, not gonna lie. I wonder if there's a more optimal solution, but doing this on live is just nerve-wracking. Let's see. Okay, let me fill up my water. Be right back. Let me check my OBS. All right, everything's good. Everything's good. Okay, we're on question 2, everybody. How long was that? I need to add timestamp later. What's the time? 42. I have 42 minutes. This guy's crazy. Okay. We're going to the second part. While the little elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, you use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. Okay, interesting. We just need to sort them. How do we sort them? Let me see. So I need to put all... After you correctly... Is there only one correct ordering? And correctly order just those updates. Let me see. After taking the... Okay, how are we going to order all these? So I'm probably thinking... Now there has to be some topological sort. So we'll look here. So we'll pretty much parse all of these. Let's look at how we can order this. Paste chart. Oh, what is that? No, I'm trying to think. I have an idea. We could just brute force it. Like for every 47, like when we look at 47, we look at all the other ones who should be to the left and throw it there. I feel like we just need to do some sort of topological sort and get a good order here. So how I'm going to do that is I'm going to look for all the ones. Let me think. Oh, we could just brute force this hard. But to actually do it optimally. So what I can do is I'll look for the first element there who doesn't appear in an after of anybody who's left. So I'll take an element, and then since I already parsed in the befores and after, if I look at a specific element, I'll just look for the first element that doesn't appear in anyone's after and place it. Then I'll look for the next element, and then I remove that from like the set of ones that I care about. Then I'll look for the next element, and then I'll place this. If it doesn't appear in anyone's let me think. So what's the dependency list here? Let me copy over a lot of this code and just delete some stuff. What's the input? Get your puzzle input. Is it the same input as before? Okay, for each of the incorrectly, use the number. Okay. We need to just parse out the ones that are incorrect. Like grab the ones that are incorrect. So we need to keep the code the same. Let's just grab this. And I'll fix that later. Okay, I'll look for each element and look for one that doesn't appear in anyone's after, because if it does appear in one of these people's afters, I can't place it as the next element. Because if I place it as the next element, it's gonna... Because when we're looking to the left... Where are we? When we're looking to... Yeah. Okay. I think that's gonna work. How much people we have in here? 5. Might be an early one today. I got a pack today too later, because I'm heading back home. Let's just see how this depend. Let's see, if else print invalid lines, and then we'll add to invalid lines dot append the line, and we'll say print invalid lines. So let's just make sure we're printing the invalid lines. It's good. What's going on? What? Oh, printing the wrong part 2. So yeah, it makes sense. We do have the invalid lines here. Now we just need to figure out so Florida man, how are you doing on the question? 53. So we grabbed the right. Okay, so we have the right invalid lines. Now we just need to do some sort of sorting on them. So for that, what we're gonna do is for line in invalid lines, let's just grab like the first element of an invalid line. Dude, it's hard, man, I'm not gonna lie. Did you get the first part though? I can show you the code. It's kind of trippy. Shit, I just spilled on myself. Okay, I'll show the code. I'll be dropping full solutions on this stuff too. So for line, we'll just break after the first one. Dude, let me fix up my chat frequency. It should be popping every single time. Whatever, I'll fix that after. So for line and invalid lines, what are we doing? For line and invalid lines, what we're gonna do is we're gonna build a result here, and we're gonna say we're gonna parse the line into a set. Real ordering went line by line. Nice. So you solved it? You have it solved, Florida? Let me check. Like you got the stars already? Nah, it's not easy. It's not easy. Okay. Did you get both stars already? You're going crazy. Four man's cooking. They're feeding them something else over there. It's like 12 at night, and he cooked that up. This guy. Okay. Okay, let me get back to this question. So I have, what I'm thinking is we're gonna take the line and we're gonna build a what we're gonna do is like for elements in the range of the length of the line, what we're going to do is we're gonna look for a candidate. We're gonna grab a candidate, or let's see candidate. We'll do candidate elements equals pretty much like the set of all the things in the line, and we'll say while there's candidate elements is greater than 0, we're gonna figure out which one we need to place. So we're gonna say for elem in candidate elements, what we're going to do for every element in candidate elements, we're gonna see if like we can add it to the result. And how we're gonna do that is we're gonna pretty much loop through every other thing for comparison. For comparison in candidate elements, if the elem equals comparison, we continue. Otherwise, what we're going to do is we're gonna say is like can place equals true, and at the end, if we can place the array, if we can place in the result, what we're going to do is we're gonna result.append. We're gonna place that element, and then we're gonna delete it from the candidate elements. Delete from candidate elements. Right, cool. And we're gonna delete that. Then we're just gonna check for comparison if this one appears, this element appears in anybody else's after, we can't place it. If elem is in dependencies, all depths, comparison dot after set, can place equals false, then we'll break. Then after, when we get here, let's print the result. This is like the weirdest sort I've ever had to do. Set does not dot remove. for element in candidate size. If for element in candidate elements. Wait, okay, it's changing sides. So we're gonna, while the length of result, while there's candidate elements, we're gonna look through every candidate element and we're gonna try to place it. Oh, let's just break here. Oh yeah. Looks like it printed. Dude, that's frying my, that almost fried my brain. 47. Result. Then we'll do result plus equals. We're gonna take the line, or we're gonna take the final result. Final result plus equals. We're gonna take the result, and we're gonna take the length of the result divided by 2. At the end, we'll just print out the final result. Oh, turn this thing into a int. $123. That's what it was supposed to produce. Now let's actually get the final input again. Then I'm gonna make a call to one of my other friends who's doing it and see how they solved it. How did everyone else solve it in the chat? I don't even know if this is the correct answer, but I feel like this is gonna work. Dude, these questions are not easy now. They're getting harder and harder. It's only day 5. I might get cooked by the end of it. Oh, shoot. $3062. Woo! Let's go. Finished off for today. That was hard. Sometimes you just gotta write code and not even think about it. Like me trying to explain it really actually just cooked me. But let's see how we ranked. Leaderboard or stats. Oh, nice. I placed in the top 4,000. That was, or no, is this, no, that's not how it works. Golden indicators. No, that's not how it works. Where is it? Leaderboard. What does this mean? Leaderboard, personal times. Oh, there's a better performance today. I ranked in the 5,000 for both questions. So that it looks like a lot of people are having trouble with this question today. Let me make a call. What did everyone do to solve it? I just got both and I ranked in the 5. Yo, I'm out of data. What the heck? To figure that out. How did everyone solve it? I got 6 people concurrent viewers. How did everyone solve it? These are my solutions. It's a bit hacky, but they all got the job. It got the job done. I got my stars for the day. I'm still feeling like doing one more Leetcode question or something. What's the time? It's only 9:47. Let's see. Print. We got 6 concurrent viewers. Florida man, are you in here? How'd you solve it? I'm going to be dropping a video on how to solve these questions and how I did it. Let me just review over, for everyone watching, I'm going to review over how I actually solved this. So the first one was about 50 lines of code to solve the first question. The next question was about, I don't know, 100 lines of code. That was a tough one today. Probably ended early then, now that I solved it, but I'll catch y'all tomorrow. I got to pack. I'm heading to Canada. So stay tuned if you want to see the solutions. I'll be posting my solutions, and I'm also posting videos on how to solve it and write the code for it. See y'all in the next video or the next stream. Peace out. End it.